All right, let's talk about Java. Specifically, two incredibly powerful keywords that a lot of people either don't know about or, kind of misunderstand. They solve some very specific, very tricky problems, and knowing how to use them can save you from some major headaches down the line.
So picture this. You're saving a user object, you're serializing it to a file or sending it over the network, but you accidentally save the password field right along with it. That is a massive security risk, right? And it's a surprisingly common mistake to make. Or hey, how about this one? This one's a classic. You've got multiple threads running. One thread flips a switch, changes a status flag from false to true. But for some reason, the other threads, they just don't see it. They keep operating on the old data. It can make you want to pull your hair out when you're trying to debug it.
Well, what if I told you that Java has specific, built in keywords designed to solve these exact problems? They might look like just little words, but trust me, they pack a punch. So today, we're going to break down transient and volatile. And we're basing this whole explainer on some fantastic work by Dr. Sasan Azizian. He really nails the explanation in a clear and concise way. So we're going to walk right through it to unpack what these keywords do, and more importantly, when you should actually use them.
Okay, so let's dive right in. First up is the transient modifier. This keyword is all about controlling what we call serialization, which is really just a fancy word for the process of turning an object into a stream of bytes so you can store it or send it somewhere. So what does that actually mean? Well, when you slap that transient keyword on a field, you're pretty much telling Java's brain, hey, you see this piece of data right here? When you go to save this whole object, just pretend it's not there. Skip it. This is a fantastic way to think about it. It's like you're packing up your house. You've got a big moving box and you're throwing stuff in, but you take your wallet and your keys and you put a bright pink "Do Not Ship" sticker on them. The movers will pack the box, but they know to leave those specific items behind. Transient is exactly that sticker for your object's data. And this diagram just lays it out perfectly. Look, we start with an object that has three fields, A, B, and C. But notice C is marked as transient. So when the saving process kicks off, fields A and B get written out, but the process completely jumps over C. What's the result? The final saved object only has A and B. It's clean, it's simple, and it's way more secure. All right, let's switch gears. We're moving on to our second keyword, which solves a completely different kind of problem. Now we're entering the wild world of multi-threading with the volatile modifier. Volatile is all about one thing: visibility. See, in multi-threaded apps, to make things faster, each thread might keep its own private, cached copy of a variable. The problem is that copy can get out of date. Volatile basically says, nope, we're not doing that. It forces all reads and writes to go directly to main memory, so every single thread is guaranteed to see the most up-to-date value. I absolutely love this analogy. Imagine you're at a huge basketball game. If there wasn't a central scoreboard, everyone in the stadium might have a slightly different idea of the score. Volatile is that giant live scoreboard hanging in the middle of the arena. When the score changes, it's updated there immediately, and every single fan, or in our case, every single thread, sees the exact same correct score at the exact same time. No confusion.
Okay, this slide really hits the point home. On the left, without volatile, you've got chaos waiting to happen. Thread A makes a change, but thread B is just looking at its old cache note and has no idea. This is how you get those bugs that are impossible to reproduce. But on the right, with volatile, that update is forced into main memory. Thread B is guaranteed to see it. It creates order and predictability.
All right, now for the main event. We've seen what they each do on their own, so let's put transient and volatile right next to each other. We need to be super clear. These two are not interchangeable, not even close. And this table just says it all. Transient is all about exclusion. Its whole job is to skip fields when you're saving an object. Volatile, on the other hand, is for visibility. Its job is to make sure all your threads are on the same page. Two different keywords solving two completely different problems. So, let's get practical. The most important thing is knowing when to actually pull these tools out of your toolbox. So let's break down the key takeaways. Here it is, plain and simple. You use transient for stuff you never want to save. Think passwords, temporary calculations, or things that can't be saved, like a network connection. You use volatile for a shared variable, like a stop flag for a thread or a shared counter, where it is absolutely critical that every thread sees the most current state right away. And that really is the perfect way to put it. It's so easy to just gloss over a single keyword when you're learning a language.
But as we've seen, Transient can literally stop a major security breach, and Volatile can save you from those nightmare concurrency bugs. Knowing which tool to use for the job is what makes your code not just work, but be truly robust and reliable.
So that's our look at transient and volatile. And it kind of leaves me with a question for you to think about. What other simple keywords, maybe in Java or any other language you love to use, hold some surprising hidden power? Thinking about those little details? Well, that's what makes us better developers. Thanks for tuning in.